So here's a question from earlier today where you were asked what is the equation of this line. So if I just pick this point here, oopsie daisy. So here's a question from earlier today and where we had to work out what the equation of this line was. So the question was write down the equation of the line L. So let's look at what point this line goes through. It goes through this point, this point, this point, this point. And can you see a pattern there? What is always the same? Which value is always the same? There's always a value that's always constant. So let's pick this point. That would be x is 3, y is 5. This point, x is 3, y is 4. This point, x is 3, y is 3. This point, x is 3, y is 2. This point, x is 3, y is minus 1. X is 3, y is negative 2. X is 3, y is negative 3. X is 3, y is negative 4. So what can we say is always x is always? Yes, correct. That would be x is always 3. So the answer is x equals 3. Plug that in, we will get a gradient of 1. So the gradient is 1. So just to remember that we have y equals mx plus c. Remember what c was? C was the point that this line meets the y-axis for the first time. So if I rewrite that, that would be y equals, the gradient is 1, so you can write 1x, and the point, this point here, the point at which it crosses the y-axis for the first time is 0. So c is 0. Now looking at this, we may be able to simplify this. Okay, 1 plus 0 is just 1, and here we have y equals, well, so if this is now redundant, 1x, that's the same as x. So the equation of this line is y equals x. And we can see that if I pick this point here and I say when y is 1, what's x? X is also 1. When y is 2, x is also 2. When y is 3, x is also 3. So we know that this is the correct solution. Okay, here's another one. You may want to pause the video and have a go at it yourself. Yeah, pause. Okay, so I assume you've had a few minutes to have a go at this yourself. So first thing I would do is I will pick the point. So I need the coordinates. Okay, so this is the coordinate here. So I'm going to pick that point because I know this point here is, so the x is 6 and the y is 4. Okay, that's why we pick those points. I say not here because it's difficult to pick the points visually. Well, it's by the eye, whereas that point there I can see what it is. And again, I can pick this point, I can pick this point as well. Okay, I can pick this point and I can pick that point. It will still give me the same answer. You have a go at it, but I'm gonna pick this one here for now. And if I just draw a quick triangle there. Okay, so we have the rise here being 1, and the run here is 2. So if I plug that in, rise over run, that would be 1 over 2, which is a half. Remember our formula for straight line graphs? Yes, so y equals mx plus c. So let's do some substitution. M is a half, so m is a half, so that would be 1 over 2x. And where at what point does this line cross the y-axis for the first time? Yes, it's 0, 1. Okay, so it's 0, 1. So the intercept here is going to be plus 1. Okay, and of course here would be y equals half x plus 1. And that is the solution for this question here, half x plus 1. Okay, so here's another question. Pause the video and have a go at it yourself, and we'll go through the solutions together. Go ahead and pause. Okay, so this question here, it's a bit different to what we've seen. The lines we've looked at previously looked like this, but this is a downward slope. So if you imagine that you're standing there, you will be sliding, yeah, for lack of a better word. So you'll be going down, imagine going down a hill, even though now we're not allowed to be going outside. So let's look at this point here. So we have what am I doing? I think that's right. Anyway, let's pick something else. So let's pick this point here and this point here. So if I draw the line across, so that would be coming down 5 steps and going across 2 steps. So 1, 2, 3, 4. Madre mia, it's 4. 4 steps. So going down 4. So we're going down, so it's a minus. Okay, so we're not rising, it's the opposite. And then the run is a positive run. So let's put this point into to find the gradient. Let's put this point, this values into the equation. So to find the slope, that would be negative 4 over 2. So that would give us a negative 2 gradient. So the gradient would be negative 2. So if I write down my formula, so we have y equals 2x plus. So let's see. Now, oh madre mia. So let's see. So we have the reason why I wrote a plus here is I'm just going by the general formula, which is y equals mx plus c. Okay. Now, at what point does this axis cross? At what point does this line cross the y-axis for the first time? It is indeed there, this point here, which is a positive 4. So the equation of our negative there. So the equation of our line is going to be y equals negative 2x, because it's a negative slope, we're going down a hill, plus 4, because that's the point at which it meets the y-axis for the first time. So this line meets our friend here, the y-axis, at this point for the first time. Here is another question. You may want to pause the video and have a go at this yourself, and we'll go through the solutions when you're ready. Okay, so we need to find the slope. So the slope is going to be, we're going down. Okay, this time I'm going to count. So 1, 2, 3, 4. Actually, so this time we're going to work the slope. So if I pick this point here, I know those coordinates. It's a nice place. And again, I can see that this one here cuts the edge of the line. We want it right there. Okay, we're not here. Nope, not there. But we want it somewhere along the lines of the edges. Okay. So at this point, so let's go. So we have 1 down. So we're going down 1. So it's a negative 1, and we're going across to get to this point 2 steps. So that would give us a negative 1 over 2. Okay, which it's okay, so we have negative 1 over 2, negative half x. And so we need, at what point does it cross the y-axis for the first time? Well, it's 4 again, positive 4. So the equation of this line is y equals negative 1 over 2x, that's a 2, plus, Okay, here's another question. Pause the video and have a go at this yourself, and then we'll go through the answers in a second, or when you're ready. Okay, welcome back. So let's see how you did with this question. So my approach would be, so this question, let's just read the question out first. We're told the points 0, -1 and 4, 5 are on a straight line. Write down the equation of this line. So 0, 1 is this point here, and this is the second point. So this time I could do the same thing. I could use the drawing the triangle, but instead I'm going to go with the formula that I showed you in another clip, which was y2 minus, actually I don't want to confuse you, it'll be y subscript 2 minus y1 over x2 minus x1, and this here is to give you the gradient. So this is to find the gradient slash slope. So let's label I'm going to label it here. So I have my x1 and my y1. So my x1 is going to be 0 and my y1 is a -1. My x2 is a positive 4 and my y2 is also a positive 5. So if I plug this point or these values into this formula, I will have y2 as being 5 minus -1 over x2 is 4 minus 0. So that gives me 5. Two negatives give me a plus, so that'll be 5 plus 1. So that'll be 5 plus 1 over 4. That is going to give me 6 over 4. Excuse me, 6 over 4. So my gradient, I'm going to leave it as a fraction for now because I haven't been asked to simplify. If I simplified it, that would be 1.1.5. Okay, 1.5. But I'm going to leave it at that for now. So we have y equals 6 over 4x. Now, at what point does it cross the does this line cross the y-axis for the first time? So there's my y line, okay, and this, it crosses at, yes, you've got it, -1. So the formula for this, the equation for this line is y equals 6 over 4x minus 1. That would be the solution. Or you could simplify it. If I just get a different colored pen, and you could have simplified it, in case you did, that would be y equals 1.5x minus 1. Okay, that's another way you could have done. Or alternatively, you could have done also y equals 3 over 2, just simplifying that, x minus 1. So there's different possibilities that you could have got your solution, and with maths, you know, there's more than one way to get to this solution. It's by efficiency. Okay, so this is a level 2-3 type of question. You might want to pause the video, have a go at it yourself. Yes, pause the video and have a go at it yourself. Okay, so how did you do on this question? It's definitely different from all the others that we've seen before, in the sense that there's no visual representation, but I'm sure you did well. So let's see if your working out is similar to mine, and this is one way you could have done. So just remembering that we always write down y equals, just in general we'll write down, but that is the equation of a straight line, and we also need to work out the gradient. So the gradient we used last time, the formula I showed you last time, was y2 minus y1 over x2 minus x1. And if I plug these values, my coordinates into these values, y2, so this is x, that's x2, that's y1, and that's y2. So my x2 is 4, and then it's a minus because there's a minus there, we're subtracting, and that would be 12 over x2 is 10 minus 0. That would give me 8 over 10. And if I simplify that, I get 4 over 5. Of course, it's a negative. It's a negative. Negative 4 over 5x. Because we're doing 4 minus 12. So imagine you have £4 and someone's asked for £12. You have to go into a minus, into debt to pay them off. So this is why it's a negative 4 over 5x. So we worked out what our gradient is. The gradient is y equals so far negative 4 over 5x now plus c. Now at this point here, if we draw this graph, here, this is I don't want to. Okay, so if you have a straight line and then you have, okay, this point here, okay, the intercept is always at this point here, okay, is 0, and then so it'll be 0 something, x is 0, and then it'll be something else. Not always, but in this case. So hence why we have 0 there, so we know that this is the y-intercept. Okay, that is a y-intercept. So that would, you want to look at the last video and see how we did it. So that would be the y-intercept c is 12. Now, of course, at this point we also have a dilemma. You could leave your answer this way, but I think you haven't been told, but you are expected to have your answer in the form ax plus by equals c. Okay, if you're not sure, maybe have a look at the lesson or email me and I will see what material I could send you out. But for now, we just need to have our x's and y's together and then c on its own. So how can we do that? Well, I'm going to multiply everything in this here by 5 because I don't want it as a fraction. Okay, so then this will give me 5y, 5 times y equals, now when I multiply 4 over 5 times 5, can I show you that somewhere? So if I have 4 over 5 times, it's a negative there, over 5, that is going to be 4 times 4 times 5, which is going to be 20 over 5. What's 20 divided by 5? 4. So because it's negative, in other words, we're multiplying by 5 to get rid of this 5 there. I hope I didn't confuse that much, but that's the idea. Okay, so that would give us a negative 4x plus 5 times 12 is 16. So what we have now is let's go down a bit. What we now have is the following. We have 5y equals negative 4x plus 60. Remember what I said, we want it in the form of, in this form, ax plus by equals c. So I need to have my y's, my variables together. So in order for me to do that, I would add 4x to both sides, and that will give me, if I just write down 4x just because it's smaller, plus 5y equals 60. So there is your answer that I think you expected to enter. But if you have the solution y equals 4 over 5x plus 12, then that is also correct, unless someone has a different idea of why it isn't. You can email me. But yeah, this is what you expected to enter on the system. But if you have this, then this is also correct for the equation of the line. So that is correct. Thank you, and see you on the next session. Bye for now.